Hello. So now we'll go over using distance in your on the game. So if you look at your game file, there's a line length program. I'll be honest with you, the line length program is really not necessary, but because we're going to square it, and when you square it, it makes it positive. So if A is greater than B, you do A minus B. Otherwise you do B minus A. So what this does is make it positive. It's like an absolute value function on your subtraction. So it does subtraction and takes the absolute value. It's kind of like what we did with mean absolute deviation. Okay. All right. So to calculate missing lengths, what does okay. So to find the distance, why does it keep jumping to that page? Okay. So and calculate distance. So to calculate distance, we use the Pythagorean theorem. That's on your reference sheet. It's a squared plus b squared equals c squared. Okay, so if you take, say, so if we solve this for c, we're going to take the square root of both sides. We get c equals the square root of a squared plus b squared. Okay, so so if you take, say, 162 and square it, and then add 317 and square it, and then take the square root. Okay, I'm going to open up a new Pyret file. How do I open it? Where's new view? I don't know. I could probably just type it in over here. So you do square root. We had 162 squared. And so you can do like num squared is num sqr. You have to put a space between the parentheses between the operations and what you're plugging in. Okay, so this, we're squaring the numbers. And then we squared the numbers, and then we add them together and take with square root. Oh, oops. I just typed num sqr. So it's not defined. Did I run this? Do I have to do num sqrt? I guess I have to do num sqrt. So I thought you didn't have to, but you do. Okay, so that's, I should have got like, what did I do? Why did I put 317? Okay, so I should have done 272. You square the legs, add those together, and then take the square root. Okay, so I should have done 272. So on Pyret, to take the square root, it's num dash sqrt, and then the square is num dash sqr. Okay, and so that's about 317, like on the thing. So to find the one that's missing, we do the square root. I gotta change the card. So we do the square root of 174 squared plus 143 squared. So in your thing, you do num dash sqrt num squared, and we're going to put in 174 and put in 143. So, and then you would press enter to get your answer. Okay, so that's how we do find the distance using the two legs in a right triangle. Okay. Okay, so do the policeman and the bike on your own. Where did it go? Okay. And then okay, so this is a way to prove the Pythagorean theorem. If you count up the squares on this, okay, count up the squares and see how many squares you get on the small sides, on the legs, and on the hypotenuse, and how those relate to each other. And how does that relate to a squared plus b squared equals c squared? Because you can think of the a squared as the area of this square here that's on that side of the triangle. B squared would be the area of this square that's on the b side. And c squared would be the area of the square on the hypotenuse. Okay. So, like in ancient Greece, they did most of their math as geometry. So everything was represented with geometric shapes. So like squaring something they would actually draw a square. And that's probably where the term square comes from. Okay, so if we look at this code, we have num square root, and then you have num squared, and then line length 9 and -3, and num squared, and line length 3, -2. Okay, so the 9 and the -3 Okay, so if we look at this coordinate here, we have 9 and positive 3. And this coordinate down here is negative 3 and negative 2. So if you look at those coordinates, okay, where did 9 and negative 3 come from? Okay, so those are your x coordinates. So where do you suppose 3 and negative 2 come from? Yeah, those are the y coordinates. Okay, so the line length function here, okay, that calculates this 9 and negative 3, that calculates this line here, the length of this segment, the horizontal segment there. And then the 3, negative 2, the line length 3, negative 2, that calculates this segment here. And it might help to put like this coordinate. This coordinate is negative 3, 3. So if you subtract 9 minus negative 3, you get that horizontal line. If you do 3 minus negative 2, you get that vertical line. And so this is one way to remember, hey, if you're subtracting a negative number, it's adding, because look, you got 3 on the top up here and 2 down here. So 3 plus 2 is the same as 3 minus negative 2. Okay, so take a moment to write down how you think this code works. Okay, so how we're going to write the code for this one. So first, you want to do num square root. We're going to do this. You put the outside function first. And then you're going to square the first length. Okay, so to get, let's do the x's. So we do 7 minus 0. No, wait, no, that's the y's. 8 minus 0. I'm going to subtract the x's, okay, and then square them. And then we're going to do the same thing. You're going to have to put a space here when you put it into Pyret. And you do the same thing with the y's. Num sqr. And then we're going to subtract the y's. And close that, close that. Wait, I think I have an extra one. Okay, and then let's copy that into Pyret and make sure it works. So we get 10. Okay, so let's think about this here. Okay, so we have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8. So this is a 6, 8, and 10 right triangle. So this is a special right triangle. Like, it's similar to a 3, 4, 5. Like, so 3 squared plus 4 squared equals 5 squared. So 3 squared is 9, 4 squared is 16, and 5 squared is 25. You add 9 plus 16, you get 25. Okay, so if you multiply the 3, the 4, and the 5 all by the same number, say you multiply 3 times 2, you get 6, 4 times 2, you get 8, and 5 times 2, you get 10. This is called a Pythagorean triple when it's integer values. And then if you take any Pythagorean triple and multiply them by the same number, you get another Pythagorean triple. So those would be sides of right triangles. Okay. So to make our circle of evaluation, so we're going to identify the values x1, y1, x2, and y2. So x1 is the x value of the first point. Y1 is the y value of the first point. X2 is the x value of the second point. And y2 is the y value of the second point. Okay, you can use line length, but you could also just subtract them. I'm just going to subtract them, but so the hypotenuse of a right triangle with legs the length of those distances is computed by the square root of the line length function squared plus the line length function squared. Okay. So the points are 0, 2, and 4, 5. Why aren't we using line length 0, 2 and line length 4, 5? Okay. So think about what is line length finding for a right triangle? Think about that. Like, see, this is points are 0, 2. So like this is 0, 2 here. And this is 4, 5 up here. So like what, if we do line length 0, 2, what does that even do? That's just like the distance this is from the origin. It's like, and line length 4 or 5 would be like there. It's just, so you have to think, well, this point down here, that would be, the x of that would be, it would be 4 and 2, right? So, like, how do you get this distance here? You'd have to do 4 minus 0. Okay, so 4 and 0 are the coordinates for this line length. And then here you'd have to do 5 minus 2. Okay, so think about what you're actually calculating. Okay, so now you could do line length, or you can do the subtraction. So you can also, you also do subtraction. So we're doing 0 and 2 and 4 and 5. So the y coordinate 2 and 5. So you do 2 and 5. And then you want to num square it. Okay, and then after you num square them, you have to add them together. And then you do the num square root. Okay, so let's rotate this around. So this is a graphic organizer. Where's the rotate feature? Okay, so do this page on your own. Where did it go? Oh, we're supposed to put this in the code. So we're going to do num sqrt, and then we're going to do num sqr. Maybe I should just type it. So we have num sqrt for square root. And then we're going to have num square. So that's the and then parentheses. And then we're going to do, they just want us to do the 4 and the 2. The 4 and the 0. 4 minus 0. And it doesn't matter what order you put them in because it's going to make it positive when you square it. And then you do num plus num sqr. And then you do 2 minus 5. And then close the square root. And then you can copy that into Pyret. And that will give you 5. So that's a 3, 4, 5 triangle. So I give you look. So 5 minus 2 is 3. And 4 minus 0 is 4. All right. So you're going to do this page 122 on your own. So you look at the screenshot and write the code to calculate the distance between the indicated characters. The first one's done for you. So basically, now you can do line length or you can do the subtraction. Okay. So do this one on your own. Okay, now we're going to write the distance function. Okay, so that takes 4 inputs, player X, player Y, and CX and CY. So CX and CY are the coordinates of another character. So you can use this for both the target and the danger. So this either CX will either be for target or for danger. So our function name is distance. And then our domain, those are the numbers that's what we're putting in. So these are all numbers. So we have number, which is your player X. And then you have another number for player Y. And then another another number for the character X. And then another number, which is the character Y. And then this is just going to give us one number, which is the distance. So then what does the function do? Well, it's going to take the square root of well, we can just write calculate distance here, I think. Because this is just telling us what it does. Okay, so say we have distance and our x. Player x is 100. Our player y is 100. Our enemy x is 150 and 200. This is going to take the square root of the square of 100 minus 150. Remember, we got to do the x's. And then we're going to square the difference of the y's, 100 minus 200. Then add them and then take the square root. Okay, and you can plug that into Pyret to see what it does. And that gives you 5. I picked another. Wait a minute. I didn't cut. What did I do? Oh, I forgot num squared. Because I was... And I forgot the q. But I was just doing a shorthand because this is just an example. What? Oh, I forgot the space because it was just an example. Okay, so it gives you about 111. Okay. So let's write our definition. So it's going to be distance and then we're given px, py, cx, and cy. Okay, and then you're going to do num sqrt, square root, sqrt for square root, and then num squared. And we're going to subtract the x's, px minus cx. And add the num squared of the difference in the y's. So that would be py minus pcy. Close, close. And that's it. That's what it would subtract the x's, square it, subtract the y's, square it, add them up, and square root. Okay, so you compare the code to the math. So, and like, what's similar and what differences are there? So how is it different? Okay, so we'll do the collision in the next one, but let's put this code into our game. So in our game, we're going to go our distance formula. So in your distance formula, where the 0 is, you're going to write num in SQRT, and then put num dash SQR, and then we're going to subtract the x's. Make sure you subtract the x's. You could also use that line length function, but it's subtracting. You don't need to do the it's gonna make it positive after you square it anyway, so you don't need to do the line length function. And then num SQR and subtract the y's. Okay, make sure you're subtracting the y's. You put the y's together and the x's together. So this will do the difference in the x's and the difference in the y's and then square it. And then we'll do is collision in the next video.